Hello everybody, Mr. Music here. On our next video, I went back and watched the last video and I sounded really boring, so I'm going to try not to sound so boring this time and see how it works out. I know it's math, so inherently it's probably a little boring, but trying to bring some life into my voice this time. Alright, let's look at number 3 and 4. This is again the chapter 6 test review. Alright, we read closely and carefully. Taylor cuts 1/5 sheet of construction paper for an arts and crafts project. So 1/5 of the sheet of paper. Okay. Write 1/5 as an equivalent fraction with the denominators shown. So here are the denominators: 10, 15, 25, 40. Okay. So in order to do this, I want equivalent fractions, so I want them to equal 1/5. Well, it tells me what I have to have the denominator be, 10. So now I just have to look at this situation and decide, okay, I have the two denominators, so that's what I want to focus in on. I don't have both of the numerators. So if I want to get 5 and get it up to 10, what do I have to multiply or divide by? In this case, we're getting bigger, so we know we're going to multiply. 5 times what is going to give me that 10? You got it, 5 times 2. Now, once I know that, I already know what I'm going to multiply the top by. Because remember, when you're dealing with equivalent fractions, you have to multiply by a fraction. Here's our fraction, 2/2. That's a fraction. But a fraction that's equal to 1 whole. 2/2 is equal to 1, and the reason being is anytime we multiply anything times 1, we get that number itself again. So we're not actually changing the value when we multiply by 1. 5 is still equal to 5 if you multiply it by 1. So this new fraction is still going to be equal to this 1/5 because we're really multiplying by 1. So 1 times 2, that gives us 2. So again, here I'm going to fill that in, a 2. Okay, let me get rid of that writing so I have some more space. Okay, I'm going to jump ahead to this one. I'm going to let you do this one on your own, but I'm going to show you another example here on this one. So again, I always start back with the number they gave you in the problem, the 1/5. This time, I want the 1/5 to equal a fraction that has a denominator of 25. Again, I start at the bottom. 5 times what gives me 25? You know your 5s. Good job. 5 times 5 is 25. And then once I know that bottom number, I know what I have to multiply the top by, the exact same number. Because this 5/5 equals 1 whole. We're not changing the value. We're getting equivalent fractions. We're not changing what the value is. 1 times 5 is 5. So now I can put that 5 above the 25. Okay? And so again, you do the same thing on this problem. You start with the 1/5, then you set it equal. I'll just set that one up for you and then I'll let you solve it. Just some fraction with a denominator of 40. Then you figure out, okay, what do I got to times by? Okay? Alright, let me clear this out again. I'm going to jump down to number 4. And we will do that one. Okay, read closely. A mechanic has sockets with the sizes shown below. Write each fraction in the correct box. Okay, less than 1/2, equal to 1/2, greater than 1/2. Now, whenever you're doing this, the easiest way to do it is compare the denominator and the numerators. Okay, so you're always looking at the denominator as your benchmark, meaning that's what you look at first. So I have 8. What I have to ask myself is, what's half of 8? Another way to think of half of 8 is to divide 8 by 2. Anytime you're thinking of half, you're dividing a number by 2. Okay? For example, if you have 10 cookies and you want to give your friend half of your cookies, you're going to divide those 10 cookies into 2 piles, one for you and one for your friend. Okay, so this takes us back to what? Second grade, third grade. 2 divided by 2 goes into 8 4 times. So half of 8 would be 4 over 8. 4 eighths would be equal to half. So is 7 eighths more than 4 eighths or less than 4 eighths? Well, 7 eighths is more, right? The numerator is bigger. So 7 eighths would go into this category of greater than 1/2. All right. Now let's look at the next one. I'm going to delete my writing. Again, you can always rewind the video if you want to go back and look at something that I've erased. Okay, so next let's look at the 3/16. Again, my benchmark is the 16. So what's half of 16? 2 goes into 16 8 times. Okay, so 8/16 would be my halfway mark. So is 3/16 less than 8/16, exactly equal to 8/16, or greater than 8/16? Well, 3 is obviously less than 8, so we go to the less than. It's less than half. So we put 3/16 in the less than box. Okay, I'm going to delete and I'm going to go over one more example. Okay, I'm going to skip 1/4. You can do that one on your own. I'm going to skip 3/8. You can do that one on your own. Again, you're using the same strategy that I showed you in the first two. You can use it again here. And then I'm going to go over 4/8. Okay, so again, I use the denominator as my benchmark, and I want to see what's half. What's half of 8? That'd be 4. So that tells me that 4/8 would be exactly half. So is 4/8 less than 4/8, equal to 4/8, or greater than 4/8? Well, obviously 4/8 is equal to 4/8. They're exactly the same, and we used our benchmark. Half of 8 is 4/8, so this would go into the it's equal to 1/2. Okay, so we did this one, we did this one, and we did this one. I'll let you do the other 3 on your own, but you can use the exact same strategy. Okay. Alright, hope that was helpful, and I'll see you on the next video. I also hope I was a little less boring that time.